It was English science fiction writer H.G. Wells that said statistical thinking will one day be as necessary for efficient citizenship as the ability to read and write. In this lesson, we're going to compute quartiles and interquartile range. We're going to create a frequency distribution from a set of data, and we will use a box and whisker plot and stem and leaf plot to determine information. All to answer the question, how can statistics help you negotiate the sale and purchase of a car? Before we get into it, let's make sure we're ready for this lesson by taking a look at warm-up number 2. Laura has grades 88, 92, 84, and 86 on her first 4 math tests. Find the 5th grade for each situation. First, she would like to have an average of 90. In order to do this, we're going to set the numerator to be all of the known scores and an unknown score x. Average them by dividing by 5, and we want this to equal 90. Now, if we multiply both sides by 5, then we will get on the right side 450, and on the left side 350 plus x. Now, by subtracting 350 from both sides, we see that she needs to have a 100 in order to have a 90 average. But what if she wanted to have an 85 average? Well, we would do the exact same thing, except we would be dealing with an equals 85. So that means on the right side, instead of 450, we would have 425. And when we subtracted 350 from that, we would find that she needed at least a 75. Now, let's take a look at a problem that you will be able to do by the end of this lesson. The following box and whisker plot gives the purchase prices of cars of 114 seniors at West High School. Are any of the prices outliers? Well, we know that the interquartile range is Q3 minus Q1. In this case, that's 9,100 minus 5,200, which is going to give us 3,900. So the first quartile minus 1.5 times 3,900 will give us a negative 650. And I doubt anybody was given $650 to take a car. To find the upper outliers, we're going to take the third quartile, add 1.5 times the interquartile range of 3,900 to get 14,950. There is at least one upper outlier, the higher price of $43,000. From the box plot, we cannot tell if there are any other outliers because the box plot does not give all the original data. Box plots are drawn to scale, so the long whisker on the right means that there could be more. You are planning to buy a used car. How can you tell what a reasonable price is for the car that you want to buy? You can find a lot of information about used car prices on the internet. You can also visit used car dealers. The prices of any car depends heavily on its condition and how desirable it is in the marketplace. You will probably spend a few weeks shopping for your car. You can determine a reasonable price for a particular car by examining the prices of those and similar cars listed in classified ads. The Kelley Blue Book or Edmunds are 2 of the many excellent resources on the internet you can use to find the value of a used car. Ask questions as you do your research. You can contact sellers to find out about their cars. Be smart in your search and, if possible, bring a knowledgeable person with you when you go to test drive the car. As you search, compile a list of advertised prices for the car you want. Then you can use statistics to help analyze the numbers or data as you compile. The measure of central tendency represents typical values for that data. You will find less variability in the prices of new cars because all new cars are in the same condition. The price you will pay is based on the sticker price of the car. Different dealers can give different prices, and it is best to compare deals when buying a new car. Used car prices vary greatly, and a skilled negotiator will have an advantage when buying or selling a used car. In the first unit on discretionary expenses, we learned about measures of central tendency and measures of dispersion or spread. We also learned that outliers are items of data that vary wildly from the bulk of the data. This definition is a little too vague for mathematicians. Here we're going to extend our knowledge to measure of spread and introduce a formal definition of an outlier. If you want to find out more about how the numbers are dispersed, you can use quartiles. Quartiles are 4 values represented by q sub 1, q sub 2, q sub 3, and q sub 4 that divide the distribution into 4 subsets that each contain 25% of the data. Now let's create a frequency distribution from a set of data. Let's find the quartiles of tire pressures of car tires at an auto clinic. Tire pressure is measured in PSI, or pounds per square inch. Now these numbers are in ascending order. Q1 is the first quartile, or lower quartile, and 25% of the numbers in the data set are at or below Q1. Q2 is the second quartile. Half the numbers are below Q2 and half are above, so Q2 is equal to the median. Q3 is the third quartile, or upper quartile, and 75% of the numbers are at or below Q3. Q4 is the maximum value in the data set because 100% of the numbers are below that number. The subscripts identify each quartile. To find the quartiles, first find Q2 because Q2 equals the median of the tire pressure. So Q2 is 31. For Q1, we're going to find the median of the numbers below the median, which are 15, 17, 21, and 25. The median of these numbers is 19, because 17 plus 21 divided by 2 is 19. For Q3, we're going to find the median of the numbers of the data set that are above the median. So 32, 32, 32, and 34. The 2 middle numbers there are 32, so Q3 is 32, and the maximum value of the data set is 34, so Q4 is 34. Let's check our understanding of this. What percent of the numbers in the data set are above Q3? That would be 25%. What is the difference between Q1 and Q3 in the data set that we just looked at? The difference, Q3 minus Q1, is called the interquartile range, or the IQR. The interquartile range gives the range of the middle 50% of numbers. The small interquartile range means the middle 50% of the numbers are clustered together. A large interquartile range means the middle 50% of the numbers are more spread out. To find the interquartile range, we're going to subtract Q1 from Q3, or we're going to do 32 minus 19 to find 13. Now let's check our understanding and find the interquartile range for this data set. The first thing we're going to do is find the second quartile, which is 23. The first quartile is the middle of the bottom half, so that's going to give us 15. The third quartile is the middle of the top half, or 31. To find the interquartile range, we're going to do Q3 minus Q1, or 31 minus 15, which will be 16. Can we find the outlier for these tire prices? The interquartile range is used to identify outliers. Outliers may occur in the lower and the upper end of a data set. Numbers are in ascending order. Now, the median, or Q2, is 146. We can find that the first quartile is located at 98.5. That's the average of 88 and 109. When we average 102 and 118 to get the third quartile, we get 210. This means that the interquartile range is equal to Q3 minus Q1, which is 210 minus 98.5, or 111.5. Now we're going to use Q1 minus 1.5 times the interquartile range to compute the boundary for the lower outlier. So 98.5 minus 1.5 times 111.5. This is going to give us a negative 68.75. Any number below negative 68.75 is an outlier, and there's no lower outliers here. We're going to use quarter 3 plus 1.5 times the interquartile range to compute the boundary on the upper outliers. So that means we're going to do 210 plus 1.5 times 111.5. This is going to give us 377.25. Any number above 377.25 is an upper outlier. So 545 is an upper outlier. Now let's check our understanding of this. A store that charged $545 for a tire in the example had a sale and lowered its price to $399. Is the new price an upper outlier? Yes, it is, because it is still over 377.25. Now let's use a stem and leaf plot to display information. Rod was doing internet research on a number of gasoline price changes per year in gas stations in his county. He found the following graph called a stem and leaf plot. What are the mean and median of the distribution? A stem and leaf plot displays data differently than a frequency table. To read a stem and leaf plot, look at the legend at the bottom of the plot. In this plot, the number to the left of the vertical line represents the tens place digit and the stem. A number to the right of the vertical line represents the digit in the ones place. They are in ascending order and they are leaves. The first row represents the following numbers: 11, 11, 12, 13, 17, and 19. The second row represents 20, 23, 26, 26. The last row represents 72. With one quick look at a stem and leaf plot, you can tell if there are many low numbers or many high numbers, or many numbers clustered in the center. Upon further investigation, you can find the total frequency and every item of data in the data set. This allows you to find the mean, median, mode, range, and quartile values. By counting the leaves in the plot, the entries on the right side of the vertical line, you can find the frequency is 30. Add the number in the plot and divide the total by that mean. So if we add it all up, we get 1,188. And dividing it by the mean of 30, we get 39.6. The stem and leaf plot presents numbers in ascending order. To find the median, locate the middle number. The frequency, 30, is even. So to find the mean, the number is the 15th and 16th position. The two middle numbers are both 39, so the median is 39. The stem and leaf plots may have slightly different looks depending on the information displayed. A stem and leaf plot must include a legend or key that describes how to read it. Let's check our understanding and find the upper and lower quartiles from example 4. By finding the middle of all of the lower numbers, we find a 23 for the first quartile. By finding the middle of all of the numbers over that median, we find the third quartile being 55. Let's use a box and whisker plot to display information. Rod, who was researching gas prices in example 4, found another graph called a box and whisker plot, or box plot, and it is shown here. Find the interquartile range of this distribution. Now look at the information presented in this box and whisker plot. The box and whisker plot shows all 4 quartiles and the least number. It should be drawn to scale, so it changes shape depending on the distribution. Recall that the interquartile range can be computed by subtracting Q1 from Q3. The box part of the diagram helps you find the interquartile range because it displays Q1 and Q3. So Q1 minus Q3 would give us 55 minus 23, or 32. The interquartile range is 32, means 50% of all gas prices were within this range. Notice that you can also find the range using a box plot, but you cannot find the mean from the box plot. You can use the statistics menu on your graphing calculator to draw a box and whisker plot. Let's check your understanding of this. Based on the box and whisker plot from example 4, what percent of gas stations had 55 or fewer gas price changes? Well, being that 55 is the third quartile, that would mean that 75% had fewer than 55. The following box and whisker plot gives the purchase prices of cars of 114 seniors at West High School. Are any of the prices outliers? Well, we know that the interquartile range is Q3 minus Q1. In this case, that's 9,100 minus 5,200, which is going to give us 3,900. So the first quartile minus 1.5 times 3,900 will give us a negative 650. And I doubt anybody was given $650 to take a car. To find the upper outliers, we're going to take the third quartile, add 1.5 times the interquartile range of 3,900 to get 14,950. There is at least one upper outlier, the higher price of $43,000. From the box plot, we cannot tell if there are any other outliers because the box plot does not give all the original data. Box plots are drawn to scale, so the long whisker on the right means that there could be more. In the modified box plot on the screen, $43,000 is the only outlier. The greatest price less than $43,000 was $12,500, which is not an outlier. If there were 3 different upper outliers, the modified box plot would have 3 dots to the right of the whisker, as is being shown here. Modified box plots give more information than standard box and whisker plots. Your calculator can draw modified box plots. Let's check our understanding of this. Examine the modified box plot. Is 400 an outlier? Yes, it is, because I can see that that would be the dot to the left of 510.